I hope all is well again with you and your family. How about thinking about playing some kickball? That's a good family activity, right? So playing with your family, let's say, you make a bet that you can kick a ball over a 4-meter fence that is 20 meters away if you kick at an angle of 41 degrees. Now what velocity does the ball need to leave your foot in order for it to clear the fence and win the bet? So here's a couple of things to think about here. Firstly, I noticed that I'm measuring in meters, which is why I told you to think about, right, gravity in meters per second squared is 9.8 instead of your 32. So again, we're going to be taking a half of 9.8 and getting 4.9. And then I measure, I have a horizontal distance of 20 meters. I have my angle of 41 degrees, and usually what I'm given is the initial velocity. But they're asking me, what is that initial velocity, right? Because what velocity does the ball leave your foot, right, in order for it to get over the fence and win the bet, assuming I kick from ground level. So I have, right, let's see, I mean, I kind of have a picture here, but if I draw over here, if I draw the ground, and this is my 4-meter fence, right, and I'm standing over here kicking the ball at a 41-degree angle. It's this initial velocity, right, that I don't know. I do know that this is 20 meters though. So thinking about our parametric equations where we break things up into an x component or a horizontal and a y component or a vertical, what is our projectile motion formula here? Right, we usually put the initial velocity times the cosine of the angle. Remember, that turns out to be just a number, right? So that is the coefficient of t. Right, that's the coefficient of t, only for me I have kind of an unknown portion there. And then what do I have for my vertical component? Well, we do put negative for the effect of gravity. And remember, it's 1/2 of this g, right? So that's 4.9 t squared. And then plus the coefficient of the linear term, which is the the initial velocity times the sine of the angle, which again is a number, right? This is going to be a number, plus my initial height. Oh wait, I'm kicking from the ground, so what's my initial height? Right? So the problem is, oops, I forgot my t. So I know that they are asking me for this initial velocity. That's what I'm trying to find. What else did they give me though? Right? I've used my 4 and my 20 in my picture. Right? So 20, right? I do want the ball to end up, right? I do want the ball to end up here, clearing, right? I want the ball to end up whatever path it ends up following, right? I want it to end up going at least 20 meters, and that's what kind of distance is that? Good, horizontal. So I'm going to go up here and I'm going to say, you know what? I want the horizontal component to be at least 20, right? Probably a little more actually, right? But notice that that takes an equation, one equation now that I have. I can solve this for t. And then what's true about my my vertical component? What do I want it to be equal to? At least 4, right? So now what do you have? 2 equations with 2 unknowns, right? Algebra 1 coming back. So I think what I'm going to do is take the first equation and I'm going to solve it for t. Right? What is t equal to? So that's equation 1, and then equation 2, I'm going to substitute in for t. Right? So I'm going to solve this system by substitution. So in for that t and in for that t, I'm going to put t from equation 1. So from here, I'm going to say 4 is equal to negative 4.9 t squared plus v sub o sine 41 t. And in for t, I'm going to put this. So I'm going to put 20 over and 20 over.
Oh my God, we both got it at the same time.
Notice something nice that happens in this term, right? The v sub o's go out, right? In the numerator and in the denominator. So I end up in the second line here with 4 is equal to negative 4.9 20 squared over v sub o squared cosine of 41 squared plus 20 tangent of 41, right? So take this, now I'm trying to get, what am I trying to get, right? I am trying to solve for v sub 0 here, right? So how about first I subtract 20 tangent 4 minus 20 tangent 41. I did that on my calculator. Make sure you're in degrees. And I got negative 13.4-ish. Whoops. So again, I subtracted this from the right side, and I subtracted it from the right side. And I got So now, remember what I'm trying to isolate. Sorry that that's a little messy, huh? Remember I'm trying to isolate my v sub 0, right? So I'm going to multiply both sides by v sub 0 and get squared. Hi, Duke. Come here. Oh, my doggy is venturing over here. Oh, it's because Mr. Getz and Dylan are playing a game in the other room and scaring him. Come over here. Come on. Anyway, I get negative 13.4 v sub 0 squared is equal to negative 4.9 times 20 squared all over cosine of 41 squared. And then what am I going to do from there, right? I'm going to divide everything, so I'm going to get v sub o squared is equal to all of that crap. And then I'm going to square root both of that, right? Square root both sides to get rid of the square. So type that into your calculator. Negative 4.9 times 20 squared. Divide it by cosine of 41. Squared, don't forget. Right, so you're going to take cosine of 41 and square it. And you're going to multiply that times negative 13.4. That is what you are going to divide negative 4.9 times 20 squared by. And then you need to square root that. And when I did all of that, making sure my parentheses were correct and all that, I ended up with 16.0203 meters per second. Gravity, in case you're wondering, gravity, right, is in meters per second squared because it's an acceleration. Stuff you'll actually learn again. You'll either, if you haven't learned it in physics yet, if you're in physics, you will, but you'll certainly learn it in calculus next year, and velocity is in meters per second to the first. Okay, pretty crazy, right? So just a little twist on the problem you did before, problems you were doing yesterday, where you had to solve for the initial velocity this time. All right, so moving on, we are going to move from stuff we've been doing in 2 dimensions before applications, right? What we were doing with vectors and parametrics, we're going to start doing them in 3 dimensions. So the next 2 lessons are going to be working in 3 dimension. So before, we talked about writing the equations of line in 2 dimensions on the xy plane, right? Writing vector and parametric equations in 2 dimensions. And if you go back, you will recall probably this this drawing where we were talking about the point A and B here, and we manipulated and drew some vectors such that we went from the origin out to A, and then tip to tail here out to B, and then P was our floating line, our any, right? And we realized that AP was just a scalar multiple of AB. So then we said our line in 2 space, a vector or parametric form, right? This is vector form, but I can turn that into parametric form, right? By just saying x is equal to a plus b minus at, right? That this was our equation of a line in 2 dimensions. So in 3 dimensions, it's really no different. Right? It still is the same issue, right, of creating this equation where you've got a multiplier of a line segment, and this is your initial point. So remember, we talk about this being the initial condition and AB being the directional vector. So that's what it looks like, where these are the x, y, and z components of your initial point, or a point on the line. And this is your direction vector, where you can find any point on the line by varying and changing a value of t for time. So let's start off very generically and just give you a point in space, excuse me, A and B, and they want us to write both a vector and parametric. Now that we've studied both of these, writing vector equations and writing parametric equations. Right, so to write the equation of that line, it is going to be, right, any point x, y, z on the line is equal to my initial point, and let's call that A since it came first, plus t times the direction vector. And remember, the direction vector comes from b minus a. So what is that? That is -2, 5, and 5. And you're going to subtract the coordinates of a. So that is minus -4, -3, and -5. So what do I end up getting up here? 2, 2, and 1. Oh, I wrote 5 there, but I meant 4, didn't I? Okay. Done. Oh, that's the vector equation. To write the parametric equation, just match up your x component. Match up your x is equal to -4 plus 2t sorry. Y is equal to 3 plus 2t, and z is equal to 4 plus 1t. Right? So vector equation, parametric. Same line, in 3 space. Now what else did they ask me to do? Determine the coordinates. So the coordinates would be the x, y, and z, the x, y, and z of a point halfway. Well, halfway means what? Right? A scalar. Scalar. Scale the direction vector by a half. So, what do you want t to be? Ah. So, doesn't matter which equation you use. X is equal to -4 plus 2 times a half. Y is equal to 3 plus 2 times a half. Z is equal to 4 plus a half. -4 plus 1 is -3. 3 plus 1 is 4. And 4 plus a half is 4.5. Right? Done and done. Let's look at this in Geogebra. Right? Check this out. Right? Here's the XY plane. Right? Here's the XY plane. And there's point A and B. Right? And let's see what this does. When I change time then, right, what's happening? Right? There's the line. And look at this vector here. Right? As time changes, this vector is pointing at, if you will, all the points that lie on the line AB in 3 space. Crazy, huh? Right, so notice what we have here, right? How this was built. -2, 5, 5, -4, 3, 4. C was B minus A. Pretty cool. All right, how about this? Ah, gosh darn it. Just trying to erase my pen. Given the line, I just wanted to show you another way to write it. I try to vary the way that we present you the same information, right? Given the line, x component in the x in the I direction, y in the j direction, z in the k direction, is equal to this expression, right? Notice here's my t. Right, I still have my t. I want to know, is this point on the line? So how can I, just like, think about when you were in Algebra 1, what did you do to figure out if a point was on the line? Right, didn't you plug in? So here's x. X is equal to 3 in front of the I plus t times the coefficient of I there, which is 1, isn't it? So I'm going to write x is equal to 3 plus t. What is y equal to? What? Hey, whoa, I don't see any j in here. What does that mean? What does that mean, y? What must this point be then? Good. Plus what? No, not plus, minus, right? Minus 1j. I'm sorry, minus 1t. And then what is z? Z is in front of that k, so that's 2 plus what kind of k? What's the coefficient in front of k? Right, t times 1, also a t. This is a t. So, is 4 negative 1 on the line? So what am I going to plug in? What do I do here? If I've got all of these, the x component that I was given, sorry, I had a text to answer. This is the x, so I'm going to say 4 is equal to 3 plus t. Therefore, t is equal to what? T is equal to 1. So the same t has to make everybody get me to the same place, right? In each direction. So if t is equal to 1, look at the y value I was given and put that in here. So y, I was given negative 1. Is that equal to 0 minus 1? Well, yeah, that works. So I'm feeling pretty good. Now what am I given here? The z that I'm given. Put that down here. So I'm going to say 0 is equal to 2 plus t, and t is, oh, this is not true. Therefore, is 4 negative 1 0 on the line? Nope. What else was I asked to do? Find the equation of a line containing another x, y, and z, different x, y, and z, parallel to the line I was given. Well, what does it mean in vector form to be parallel? What did we talk about before in 2D? It's not going to change. You need to have the same or multiple of the direction vector, right? So, the simplest, there's multiple correct answers to this. If I wanted to write it in vector form, I would say the given point. Or any multiple. 2, negative 2, 2, 3, negative 3, 3, negative 2, positive 2, negative 2, right? Right? Any multiple of your direction vector. Would make you parallel. Alright, moving on. Next. Write an equation of a line containing, alright, I got that part down. Ooh, perpendicular to the who? XZ plane. So XZ plane, let's see, go over here to this drawing, that's this wall. Right? So I need to be perpendicular to that wall. So perpendicular to that wall, but I have to contain the point 1, which would be here, negative 2, which would be back here, and then up 3. So somewhere here, right, I need to draw a line that is perpendicular, so like going through this wall, right? Can you visualize that? A line going through that wall. So, what do you suggest? Now, to write the equation of a line, I know I'm going to start with, in vector form, point I'm given, plus t times something. Right? I need a direction vector. And direction vectors, remember, in vector land are pretty nice, because I just need to be, and again, I'm going to pathetically try to draw this. It's supposed to be dashed. Let me try that again. Ah, that's not what I wanted to do. Darn it. Draw the wall. Draw a dashed line up here. There, it's a little better. Sorry again, answering the text here. So what needs to be true about this? I mean, this direction vector, really, I just need to have something that is parallel to that line I've drawn, right? Parallel to that line I've drawn, but I need to make sure I'm up here, right? That I get up here. So I need to make sure that, right, I go over 1 and back 3, right? But I need to get up to that point. Well, this is going to get me there. Right, that's going to get me there. How about I draw a, what is this vector right here? Do you know what that vector is? That's the unit vector. What coordinates do the unit vector j have? Truth? Right? Well, don't forget that if this unit vector, if I make this my direction vector, I'm going to multiply it up here, right? Multiply it. And it's going to be added to the 1, -2, and 3. So isn't that just going to pop it up, right? Isn't that going to take the direction? Isn't that going to pop me up here, this blue vector up here, and I will make sure to be in this line, right? Does that make sense? Kind of crazy. Let's try it out. So what happens if I put 0, 1, 0 in here? What do I get? Let's look at this in parametric form. What is x equal to? X is equal to 1 plus 0t, or just 1. Y, though, is equal to -2 plus t. So x is a constant. X is constantly 1. Y is that -2 plus my, right, plus t. That's the only change. And look at what z is going to be. 3 plus 0t. So in other words, x is a constant. X is constantly 1. Z is constantly 3. And what do you notice? Right? What's the only thing that changes? The only thing that changes is y, and actually, shh, don't tell anyone, but I actually don't really care about this. I can even say that y is just equal to t, right? That's the only only thing that's varying it, I don't even really care that it's negative 2 plus t. I just care that I pop up here with my, you know, so that I get somewhere up here. It doesn't even really matter where my negative 2 is. I just need to make sure to be over 1 and up 3, and then I don't care where I am here, right? I'm still going to be parallel to the XZ plane. Crazy, right? I mean, either one of these is right, but I have to tell you that this is more common. But it's okay if that messes with your head right now and you just like to do right? You just like to do it straight up, put the unit vector in here and multiply it out. Or just leave it like this too is absolutely fine. What if I had said, write the equation, but I wanted you to be perpendicular to the XY plane. What would that look like? The XY plane is down here, right? So same point here, but I want you to be perpendicular to the XY plane. I guess I gotta color more, huh? Right, that's like the floor. And I'm gonna go down here and then continue on down through the floor. Right? Right? What do you think you would do then? Same point. But which unit vector am I going to use this time? Right? Since it's the XY plane, right? I'm going to use the K unit vector, right? And the K unit vector has components 0, 0, 1. So I put 0, 0, 1 in there. If I wanted to write this in parametric form, X is constantly 1, Y is constantly negative 2, and Z is equal to 3 plus T. But what did I tell you? That really this 3 is free to be whatever. Free, baby! You can make that 3 anything, which means you can make it 0. Right? So I could write this as X is equal to 1, Y is equal to negative 2, and Z is just equal to T. Right? Because it doesn't matter. Here I need to make sure that my X, that I'm going out 1 unit, and I need to make sure that I am going back 2 units, but then I don't care what my height is, what my Z is. Right? My Z I need to change, but it doesn't matter how I change it. You know, I will be on this line. Cool beans, baby. Oh, gosh darn it. So I have a GeoGebra of this as well. Oops, I'm sorry, I think I mistyped that. That's, in our example, that's a 1. But here, right, so I used 1, 0, negative 2, 3 here, and the PowerPoint I have a 1 right here. But notice this is the unit vector, right? So this goes with the first, what I typed up there first, where I'm parallel to the XZ plane, right? Here's the unit vector. Here's going out to the line, right? And now this is the line that goes through, and the blue shading is the XZ plane. Right? Kind of crazy. I guess I can change this, right, so it matches our example. There we go. Right, but kind of cool, right? Woo! Right? You can see it there. They're coming out at you. Right, these links are on the PowerPoint if you want to play with them yourself. Pretty cool. Look, now it's just in motion. Nicely done. All right, how about these two problems? Explain why the lines below are parallel. Now again, mostly I just wanted to do this example because you've answered this already. You kind of, hopefully you understand what you want to look at. I just wanted to present the equations in another format. Here is your t. So this is your point, and this is your direction vector. So why is line 1 parallel to line 2? What must be true? Direction vectors have to be equal or multiples of each other. So when you're looking at the direction vector for line 1, is the direction vector for line 2 a multiple of it? And I think you can see that it is, right? Times 2, negative 4 times 2, 1 times 2, I'm sorry, negative 2, right? Negative 4 times negative 2 is 8, 1 times negative 2 is negative 2, and 3 times negative 2 is negative 6. So the first direct is E. Right? And multiply the first direction vector by negative 2, and I get the second direction vector. Now look at what they're asking me to do. And again, hello, previous objective. Dot product of the direction vectors. So again, I have to find my direction vectors. I have to know what those are. Then, remember how to do the dot product. So remember the dot product is vector 1 dot vector 2 and what do I get here? Negative 12. Product of the x's is negative 12, product of the y's is 0, and product of the z's is 12, and I get 0. What does it mean when you have a dot product that is equal to 0? Correct! Two lines are perpendicular. Good job. Next. Oh, forgot I did this too. These were the first example,
Can you bring my water
right?
over here?
The parallel ones.
Where's your water?
Right? Can you see that they are parallel? This is the first example.
The tall one here?
No, it's like my
Right?
cup of water
Parallel
right here
lines.
with the straw.
Right? And you can see them up here, right? Where the direction vectors, -4, 1, and 3, and 8, -2, -6, are multiples of each other. Lines parallel. Oof. What the heck? Do these lines intersect? If so, find the point of intersection. Oh, snap. What is this all about? Well, again, Algebra 1, pretty freaking important. So what do I have to do here? I think I'm going to organize this into into parametric form, right? For equation 1 and equation 2, I'm going to write line 1 as the x component is equal to t minus 8. The y component is equal to 2t minus 6. And the z component is equal to -2t plus 5. For them to intersect, they have to land at the same place at the same time. So in the second line, the x position is also, now in order to avoid confusion, I'm just going to use the letter right before t, which is s. You can actually use any variable you want. But I'm just going to, just to organize myself and keep these, the s's with line 2. If you don't have to if you want, time 1 and time 2, whatever. So, what am I going to do here? I need to know if these x's, for the x position, do I get to the same place at the same time? So I'm going to set them equal to each other. When does t minus 8 equal 2 s minus 1? And I'm going to do the same with the y's. When does 2t minus 6 equal t plus 2? I think I'll start there because what I have right here is 2 equations with 2 unknowns. Hello, Algebra 1. I think I'll organize this a little bit. And I'll say, let's see, I'll add 1, so I get -7 is equal to 2s minus t. And then I'll bring this 2 over here and get -8 is equal to, whoops, that's an s, isn't it? I forgot to change these to s's over here. S, S. Now there's a variety of ways I can solve this. I think I'm going to multiply this equation by -2. So I'm going to end up here with an unchanged equation. -7 is equal to 2s minus t. Positive 16 is equal to -2s plus 4t. And then I'm going to add down. So I'm going to get, what happens when I add down? I get 9 is equal to by 3t. And t, lo and behold, is equal to 3. What do you do with that now? That's the time. I keep saying same time, but I mean same location. So this is the time for line 1. To get to the same position, what does S have to be? I think I'll go back up to this equation and say -7 needs to equal 2s minus 3. So what does that mean? Add 3 to both sides and I get -4 is equal to 2s, and therefore s is equal to -2. So for line 2, the time to get to the same position is -2. So now we have to check. So for line 1, x is equal to t minus 8, which is -5. Y is equal to two times 3 minus 6, or 0. Z is equal to -2 times 3 plus 5, which is -1. So my candidate for point of intersection is -5, 0, -1, but I have to check to make sure that line 2 with t equal to -2 gets me to the same place. So does it? So for line 2, x is equal to 2 times -2 minus 1. Check, that's -5. Y is equal to t plus 2, and my t is, or my s, I'm sorry, is -2 plus 2, which equals 0. Check. How about z? Z is equal to 3 times -2 plus 5, which is -1. Check. Whoop. Yes, these two lines cross, and they cross at the point -5, 0, 1. -1. And here's that visual. Right, two lines, XYZ plane, crossing, here's the two lines, and their intersection point, -5, 0, -1. Pretty cool. Last one. Same kind of problem, just two different lines. So I notice here z is equal to t. Therefore I know already over here, right, what I've got going on. So, right, I've got a little bit substitution, kind of easy there. So this is line 1. This is line 2. And again, to try to keep things straight, if I make my t's into s's, just to keep the two situations, get it, different, I'm going to set these two equal to one another, right? Kind of like instead of solving a system, solve by substitution, and say that t must be equal to 3t plus 7. And then I'm going to substitute that up here, right? Because from that line, t minus 1 must be equal to -2s plus 1. But I have what t is equal to by the third lines. So in for this t, And again, this is not the only way to do it. There's a variety of ways to solve this. But so in for that t, I'm going to put 3t plus 7. So 3, oh bother. Three t plus 7, that's this t right here, minus 1 is equal to negative 2s plus 1. Ah! Sorry, that's an S. I keep forgetting I change it, and then I forget that I've changed them to S's. So let me write that again. 3s plus 7 minus 1 is equal to negative 2s plus 1. So I get 5s. This is plus 6. 5s is equal to negative 5, right? Because that's a plus 6. And I'm going to subtract 6 from this side. So s is equal to negative 1. Then I'm going to go back up here and say, well, that must mean that t is equal to 3 times negative 1 plus 7, which is 4. So now I need to, now that I have a t and an s, so you got to remember who is who, right? I got s to be negative 1. And over here I have t is equal to 4. And now I have to check, right? When you put 4 into here, don't you get 3? Do you get the same thing when you put negative 1 here? 2 times negative 1 is 2. 2 plus 1 is 3. So I get 3 here as well. I'm a happy person. Notice over here y is equal to negative 2, so I have to put, oh, I can already see this is going to be a problem, right? So regardless of what time is, y is constantly negative 2, but look what happens over here. When I put my t, which is 4, into here, I get 9. 9 certainly doesn't equal negative 2. That makes me sad, and I can stop now, because what do I answer? I don't have an answer to this, because what's my answer over here? Do the lines intersect? Nope. All right. Hope you had fun doing that. Shut up, Dylan. Your homework is a handout that is on Canvas, and it is lines in space. Right, so this is, you can print this out, do some homework in quotes, right, because you don't really have any homework. Right, this is optional, but that is the handout that I'm referring to here that would practice the stuff we did in this warm-up. And I did upload it in PDF form on Canvas, so hopefully the format is a little better preserved for you than when I upload Word documents. All right, have a nice rest of your day, and I will talk to you soon. Take care.